Good morning, children. Welcome to online physical science class. This is standard 8 physics lesson 6 heat. Okay, in this lesson the heading is very familiar for you and we will start up with the known things of you. The process by which a substance changes from the liquid to gaseous state is called vaporization. Isn't it? This one we have learned in our um, lower classes. What is vaporization? When a liquid converts into liquid, that is called, when a liquid converts into gas, that is called vaporization. Okay. What do you mean by boiling? Boiling at a particular temperature, the liquid begins to boil. Okay. That temperature is called a boiling point and it is a fixed one. What is the difference between evaporation and a boiling point? Evaporation, it is a slow process. Evaporation is a slow process, whereas boiling is a fast process. Evaporation takes place only from the surface of the liquid. Boiling, it occurs throughout the liquid. So evaporation occurs only from the surface, upper surface of the liquid. But boiling, all the liquid will boil. Evaporation, no bubbles are formed in the liquid. Okay, boiling, bubbles are formed throughout the liquid. Bubbles are the indication of boiling, right? Yes. Evaporation, it occurs at all temperature. See, evaporation is a continuous process, isn't it? The pond, lakes, rivers, all those waters are evaporated continuously even in the winter season also. It is not that only in summer season these water from the sources will evaporate. It evaporates even in the winter season, even in the rainy season, right? So evaporation occurs at all temperatures, whereas boiling point it occurs only in the at the boiling point. Okay, for example, when you heat the water only to 100 degrees Celsius, it will begins to boil. At 50 degrees Celsius, it won't boil. Is it right? Yes. Evaporation, the energy, heat energy required is taken out from the liquid and its surroundings. So the heat required for this evaporation is taken from the liquid itself and also from the surrounding. Whereas in the case of boiling, the heat required is supplied from outside. So we have to supply the heat energy so that the liquid begins to boil. Okay, that is either from stove or a gas or induction. We have to supply the heat from outside externally so that it will begins to boil. Evaporation produces cooling as the heat required for the process is supplied by the liquid and its surrounding. So, due to evaporation, we feel the chillness. For example, when you add some perfumes on your body, actually what happens there? The heat of your body get evaporated along with the perfumes, right? So you feel the chillness there. So what is actually happening there? The heat required by for the process of evaporation is supplied by the liquid and its surrounding. Okay, so whereas in boiling does not produce cooling as the heat required is supplied by an external source. So the heat is, since the heat is supplied by the external source, there in the case of boiling we won't feel the cooling effect. Okay children, that's the difference between evaporation and boiling. This is a very important question children. You have to remember this process always. Okay, fine. Okay, now the amount of heat required to change 1 kg of a substance from its liquid state to vapor state without change in temperature is called latent heat of vaporization. So, the heat required to change how much of substance, 1 kg of substance from liquid state to solid, vapor state, but there should not be any rise in its temperature. That amount of heat is called as latent heat of vaporization. This heat is released during the vapor condenses. What is latent? A liquid requires a particular amount of heat to change into vapor state. This heat. This is called latent. Latent means hidden. Latent heat because the heat gained by the liquid does not show any rises in the temperature of the liquid. The temperature of the liquid won't change. At the same time, the liquid requires certain amount of heat that will change the state, liquid state into vapor state. That heat is called latent. Latent means hidden. Do you understood? So, to change 1 kg of substances, what is the amount of heat required is called to be the latent heat of vaporization. Is it understood, children? Hope you have. Similarly, amount of heat required to change 1 kg of substance from its solid state to liquid state without any change in temperature is called its latent heat of fusion. Latent heat of fusion. This heat is released when the substance freezes. So, if it is converted into liquid to vapor, we call it as latent heat of vaporization. When it is converted into solid into liquid, we call it as latent heat of fusion. Do you understood this? Yes. Okay, the next topic is the change in dimensions, area or volume of a body or a substance with a change in temperature is known as thermal expansion. So when you change the temperature, if a object tends to change its dimensions, area and volume, we call it as thermal expansion. Contraction is known as negative thermal expansion. Contraction is known as negative thermal expansion. Is it clear, children? So, what is thermal expansion? When you heat a substance, if the substance changes its dimension, area and volume, we call it as thermal expansion. Okay. So, this thermal expansion occurs in all the substances. A peculiar behavior is seen in liquid, okay, that is called as anomalous expansion of water. Anomalous expansion of water. Most substances contract on cooling. Thus, the solid forms a substance generally has a higher density than liquid form. An expectation to this is water. When water is cooled, it contracts until the temperature reaches 4 degrees Celsius. After that, it starts expanding. Okay. So only up to 4 degrees Celsius it will contract. Normally all the objects when they are cooled, all the liquids when they are cooled, they will contract, isn't it? But this liquid, the water will contract only up to 4 degrees Celsius. Only up to 4 degrees, only up to 4 degrees Celsius. Okay, after that it will start to expand. And this behavior is known as anomalous expansion of water. Since water expands below 4 degrees Celsius, its density decreases as it is cooled below this temperature. So when you cool below this temperature, its density decreases because of this anomalous expansion. This is why ice floats on water as do icebergs in sea. The density of ice is 0.9167 gram per cc at 0 degrees Celsius, while the density of water is 0.998 gram per cc at the same temperature. So which has the more density? Of course, water. That's why ice begins to float. The density of water is greatest at 4 degrees Celsius, being 1 gram per cc. Okay, being 1 gram per cc. Okay, this anomalous expansion of water is great use in nature. It helps aquatic creatures survive in winter because when the water of a lake, for example, cools, it rises to the surface instead of sinking to the bottom. So when the temperature drops below the freezing point of water, only the top layer freezes. So because of this anomalous expansion of water, the water in the sources will freeze. The upper layer of those water sources alone will freeze. Inside that the water won't freeze, and this helps the living organisms to survive in those sources. Is it clear, children? Yes. So when we are talking about this thermal expansion, if a body whose length is large compared to its breadth and thickness is heated, there is a much greater change in its length compared to the change in its breadth or its thickness. Okay, whose length is large. When the length is larger than the breadth and thickness, if it is heated, there is much greater change in its length. So this is known as linear expansion. Linear means straight lines, isn't it? So linear means the expansion happens in straight lines. So we call it as linear expansion. Okay, children. Hope you have understood and enjoyed today's class very well. Meet you again in the next class. Complete your assignment and report in the group. Also prepare well for your upcoming exams, children. Thank you, children.